Good day to you, chaps. That's my British accent. Hope you liked it. But anyway, this is section 4.7 about arithmetic sequences. So we'll talk about what those are. If you know what the word arithmetic means, it's really basic math. So this section can be about, it's really about adding, basic math, doing adding. Um, but we have two goals. The first one is I can identify and extend patterns in sequences. And then the second one is I can represent these arithmetic sequences using function notation, which we learned about last time. So, a couple vocab words, and you'll understand them a lot more when we use them. But a sequence is an ordered list of numbers that form a pattern. Doesn't matter what the pattern is, as long as you can find a pattern. An arithmetic sequence, though, is a sequence that has a common difference between consecutive terms. So you add the same amount each time as you go on, or subtract the same amount. When we say common difference, that's just the difference between the numbers of an arithmetic sequence. So we're going to say difference between the consecutive numbers. Whoa, that made my definition look weird. Let's fix that. There we go. All right, and the last one, explicit formula for arithmetic sequence. That's a formula we're going to use. So if we're doing an arithmetic sequence, we actually have a formula. And this is what it's going to look like. I don't need you to write it down right now because we're going to come back to it in just a sec. But we're going to go to that first part, extending sequences. This is regular sequences. So remember, a sequence is an ordered list of numbers that form a pattern. So let's find patterns. So our first problem says describe the pattern in each sequence. What are the next two terms? So we'll do one at a time here. Letter A, 5, 8, 11, 14. So if you look at it, hopefully you can tell that each time it's going up 3. So the sequence is adding 3 each time. And then what are the next two terms? Next two terms, if we add 3 again, we get 17. And we add 3 again, we'd get 20. So that's the sequence. Let's look at B. So what's the sequence? 2.5, 5, 10, 20. Ah, well, I hope if you look at it, at least for the second and third part, but the first one it is times 2. So it's doubling every time. Times 2, times 2. So if we multiply it times 2 again, we'd end up with 40. And then if we times 2 again, we'd end up with 80. So that's just a regular sequence. It should be pretty simple if you can find the pattern. Just looking for next two terms in this case. So I'm going to let you try one on your own. Let's do, well, why don't you do both of them? First one says, what's the pattern here? It says 5, 11, 17, 23, and find the next two terms. And then the next one is, what's the pattern here? All right, so if you looked at this one, this is going up by 6 each time. So the next numbers would be 29 and 35. And B, it's actually dividing by 2 each time, so multiplying by 1/2. Divided by 2 again, we'd have 25, and then we'd have 12 and a half. All right, let's look at a specific kind of sequence. This is an arithmetic sequence. So we're going to use some basic arithmetic. Remember, an arithmetic sequence is a sequence that has a common difference between consecutive terms. So we look at our example here. It says tell whether the sequence is arithmetic, and if it is, what is the common difference? Well, let's see. So this thing goes up by 5. This one then would be up by 5. This one would be up by 5 again. So it is a sequence, an arithmetic sequence, and the common difference is 5. Look at this one. Arithmetic sequence. Plus 3, plus 4, plus 4. So I don't even know if there's a real pattern there, and they're not going up by a common difference, so no, it is not an arithmetic sequence. So if you try this on your own, I've got 4 here for you. You can do as all of them if you want. I'm just going to have you do, actually, you know what? I wanted you to do C. So let's undo that. I don't need you to do these two. So A and C, try those on your own. All right, so if you found A, it's going up by 7, then 7, then 8. So no, this is not an arithmetic sequence. C, we're going down 6. Oops. Down 6 again. Down 6 again. So yes, and the common difference is -6. Interesting. So C was an arithmetic sequence. Now, I might ask you to say, all right, here's your sequence, this arithmetic sequence. What is the 100th term? So instead of going for like, instead of saying for this one we do um, 23, then 28, then 33, then 38, until the 100th term, we got to find a shortcut. And that's where this formula comes in. So the arithmetic, it's called the explicit formula for the arithmetic sequences, and this is what it is. I'd like you to write it down, and I'll explain what it is as you write it down. But this is in function notation. So the function of a of n. So n is the nth term, or if we're saying the 100th term, we'd be looking for 100 there. It's equal to a to the first term, so that would be whatever the first term is. This part right here is the first term, whatever the first number is. The n, we plug in which number we're looking for. So if we're looking for the 100th term, that would be 100. And the d is another thing we plug in for. Again, we have -1, but the d is going to be the common difference. So if you know it's going up by 5 every time, we're going to multiply at the end by 5. If it's multiplied by -5, we multiply by -5, or if it's a -5 difference. So I'll show you how that works. So here's a real life situation. It says, an online auction works as shown below. Write an explicit formula to represent the bids as an arithmetic sequence, and then find the 12th bid. So if we look at it here, um, so it's a guitar. We're bidding on a guitar. So the first bid was 200. The next one was 210. The next one was 220. The next one was 230. So hopefully you can tell here, if you were to rewrite it like this, that it's going up by 10 each time, which means it is an arithmetic sequence. So let's use our formula. Let's use that formula a, and we're going to find to the 12th. Well, we'll do a to the n first. Equals a to the first, which would be the first. And then I think it's plus or minus. Plus n minus 1 times d. So instead of that, we're going to actually fill in some things here. We're going to do the 12th or the 12th one. So we want to find the 12th term. So we're going to say that would be a to the 12th is equal to the first term, which in this case our first term is 200. That's our first term. Which term we're trying to find. So we're going to do, so plus 12 is going to go in there. We're trying to find the 12th term, so minus 1. And then at the end, that's going to be times the common difference, which is 10. So remember, that is the common difference. All right, and really we're just doing order of operations then to solve it. So parentheses first would mean we do 200. We do this part first. So we do 200 plus 11. That's 12 minus 1 is 11. Times 10. All right, no exponents in there. So let's do multiplication next. So we do this part right here. So it would be 200 plus 11 times 10 is 110. And then we just have addition left, which is going to be equal to 310. So the 12th term is 310. So instead of adding 10, 10, 10 for 12 times, we can tell the 12th term is going to be 310. That's the nice thing about this formula. So we're going to try one more. I would like you to use the arithmetic formula to find the 15th term in the sequence. And I'm going to actually go through this one with you. So again, we're going to use that formula. I'll write it out again. Here we go. All right. So if we look at this, our common difference, it's going up by 7 here. Goes up by 7 here. Goes up by 7. So this is an arithmetic sequence. It's going up by the same amount every time. So that difference is going to go right in there. The first term, which is 6, is going to go right in the front here. And since we're trying to find the 15th term, that's going to go on for n. So the arithmetic sequence looking for the 15th term is going to be equal to 6 plus 15 minus 1 times d, which is the difference is 7. So again, we're going to do order of operations then to solve this one, to finish it up. So we do the parentheses first, which is 15 minus 1. So we have 6 plus 14 times 7. Multiplication comes next. I don't know 14 times 7 off the top of my head, so I'm going to go to my calculator. So 14 times 7 is 98. So that's 98. 6 plus 98 equals 104. So the 15th term in this sequence would be 104, just by using the formula. Awesome. So that is it for arithmetic sequences. So just identifying and extending patterns in regular sequences, and then using the arithmetic formula and function notation to find patterns in arithmetic sequences. So hope you learned something. We'll do more of this next time. Have a good rest of your day.